السلام عليكم. إيه، إذا الصوت واضح بليز يعني write في الشات بليز. أوكي ممتاز. So good evening everyone and welcome back to the second day of Azeer online course. I am really exciting to see you again. Yesterday we have covered the ELISA 800 course, which is covering all the features, mood, the accessory, and what is the outcome for using all the features in ELISA 800. So today we are going to present high frequency ventilator, Leoni plus high frequency ventilators. Before we start, I will just introduce myself. My name is Saad. I am a marketing manager in Azeer company. So I have experience for 15 years in King Fahd Medical City as a respiratory therapist. So now I will share the file for starting our presentations. So starting with our presentation today, we are going to present the Leoni Plus. Before we start, I will just confirm that you have seen our presentations. If you didn't see it, please share, send it in the chat, please. Okay. So starting with our Leoni Plus, as you know, we have Leoni Plus. We have two machines, two devices in Leoni Plus. One for ICU ventilators using in ICU, and there is a red one is for the Leoni Plus transport. This is the first ventilator, neonatal ventilator, high frequency, can be used during the transport. For the Leoni Plus, we have the high frequency, conventional, high flow, all this respiratory support, you can have it in one ventilator. So as you see here in our Leoni Plus, we have a Leoni Plus ventilators in ICU utilized, and we have a Leoni Plus transport, the red one. It's the same concept, same principles, same features, only this one is approved for the transport and we can be used the high frequency during the transport. So before we start to explain about the high frequency, we need to just focus more about the high frequency intent to use for the neonatal patients, for the pediatric populations. Starting from how much the device with the ventilation mode high frequency have printed in the front panel. So as you know, the patient Leoni Plus is ventilator for invasive, non-invasive ventilations, starting from 350 gram up to 30 kilo. Can be ventilate the patient from starting from severe premature baby 350 gram up to 330 kilo. That means covering all neonatal and the pediatric populations for the conventional set. For the high frequency principles can be used from starting from 350 gram up to 12 to 14 kilo. That means covering all neonatal plus pediatric, half of the pediatric populations. So starting with the ventilator Leoni Plus, it's the, as you know, ventilator front. You can see we have only the keyboard. So we have only the manual for the confirmations. And in the below, you can see we have number 8 is the expiration valve membrane. We have number 5 and 6. The 6 is for the abdominal pressure sensor monitoring, and the 5 for the pressure measurement monitoring. For the 4, number 4 is for the inhalation circuit. Here, as you know, in the back side, you can see we have the number 8 and 9 is for the fan filters. We have number 2 is for the SpO2 sensor connections. We have the manpower. We have also oxygen connections or oxygen cells connections. We have also the electricity plug, as you see here. So in the back side, you have also number 1 for the retrieving the data. You can retrieve all the data from the USB connections. Also, you have oxygen connections. So number 4, as you see, we have flow sensor connections in the back side for the flow sensors connections for the neonatal populations. So in the back side, back to the front side, as you see, we have number 6 is for on and off in the green color. Number 9 for the starting the mode. For number 12 is for adjusting the setting and confirming the settings. So this one is can be seen. And for number 2, as you see, number 2 is for monitoring and between the two numeric tables. And number 3 is for alarming set. Just click here and you will have the alarm set and the auto alarm set. Continue with the front panel. As you see, we have all this one informations for the alarming mode, everything you can find it in the front panel. So here there is explanations for the waveform and the abbreviation found it in the front panel. As you see the graph here for the loops, just click for the loops. You will have the open window for the loops, and we can select the frame for the loop. If you want pressure, volume, or volume flow, you can select it what you like. And for the chart, you can click in the chart panel, then you will have the chart window. Then you can select the frame. You have up to 3 chart waveform, flow, pressure, and the volume. So also in this graph, under this abbreviation or this table, you can find the alarm limit. If you click on it, you will have the alarm limit value monitoring. For the monitoring, you have 2 pages. You can click on this and you will have more. In the first pages, you will have all this manometer measurement. If you click the second page, you will have additional barometers also. Here in the yellow green, you have the start. If you start ventilations, confirm change for ventilation mode, or stop pause the early, only this one from this panel, you can click on it to start ventilation. Shifting from invasive to the non-invasive, to confirm, you have to select on that. In the green panel, you can see we have on and off. You can switch on the device, stop ventilations, switch off the device, all this one from the green panel. So also we have abbreviation in the front panel is called MAN. MAN is the manual breath. It's only activated during the high frequency mode. So if you click on that, you will activate the manual breath. Okay, but if you remove your hand, then the manual breath will stop. So as you see here in this slide, we have a full setup of the ventilators. We have 12 inch touch screen with the full setups should be with the active humidifiers, as you see here, and the proper connections for the neonatal ventilation should be always in active humidifiers. Why? Because the patient is already inside in the incubators, and you need to control the temperature of the circuit by active humidifiers. So as you see here, the full setups for the active humidifiers for the inhalation, exhalations, and the pressure measurements. As you see here, you can connect the full setups for the inhalations, exhalations, and the patient is already connected in the test line. You can have it with the active humidifier. What is the great options in our ventilator? It is open system, so you can apply all the active humidifier, any kind of active humidifiers. Also, you can use any kind of the circuit. There is no specific circuit can be used. Even if you during the high frequency, you can use any kind of circuits. That means it's open system, can be used any device or any accessory that you use in your hospital. So as you see, we are completing in the setup for the inspiratory high frequency. We have it here, the expiratory, the valve, expiratory valve membrane. So the circuit should be connected here. For the number 3 is the inhalation, inspiratory connections. And for the number 2, as you see, we have the pressure measurement should be connected and up to the flow sensors. And here in the upper side, we have the pressure, abdominal pressure connections. So for the non-invasive ventilation mode, connect the pressure measurement tube adaptation set should be. Connect the aspiration tube via the bacterial filter. Should be the inhalation tube, should be have the bacterial filter. So this one is the proper set for our ventilators. As you see here, continue with the setup. We have abdominal sensor. Is really a great options to measuring or monitoring the synchronizations for the breathing. As you know, for the non-invasive baby, there is a difficult synchronization with the ventilator, with also the breathing of the baby. So this abdominal sensor can be connected from the ventilator, touching to the abdominal of the neonatal is very soft. There is no side effect for the baby. Then after that, you will open window for the baby to have a better synchronization with the diaphragm. So this one is only active during the non-invasive synchronization mode. It's really a great option to have abdominal sensors or a better synchronization for the baby through the abdominal sensors. This is the first ventilator can be used these options. So here we have a full setups or the B setup for the IV ventilation. As you know, for every ventilator, we have to connect the baby with the flow sensors here, as you see here in number 4. And we have a YBs for the inhalation and exhalation number 2. And number 1, as you see, we have the pressure measurement should be connected. This one is a full setup for every invasive ventilation that you use for the baby. Number 4, you can use the flow sensor can be used disposable or reusable, and we have the YBs for inhalation and exhalation. Number 1, it's for the pressure tube to have accurate measurement for the baby. Here we have for the non-invasive closed system, As you see, for the non-invasive, you can use any type of the interface, can be facial umbilical or the new jet generations. So they can connect it from here. You can remove the flow sensor. There is no require for the flow sensors. Then connect the pressure measurement here. So it's very simple setups. Only need from you to connect the interface here with a proper adapters. So here we have, in the next slide, we have high flow setups, how you can connect the high flow setup for the neonatal population. It's similar to the non-invasive. It's only YBs connected with the pressure measurement, and you can use any kind of the high flow that you are using in your hospitals. This only example the RAM cannula, as you see, RAM cannula with a good adapter. You can connect it number 4 RAM cannula, then you can run out the high flow therapy to your baby. So this ventilators or this Leoni Plus ventilator can be used all respiratory support, invasive, conventional mode, high frequency, VG. Also, you can use the non-invasive mode plus the high frequency non-invasive mode plus we can utilize also the high flow. So all respiratory support can be delivered to the baby with our machines. Here, as you see in the flow sensor, we have two types of the flow sensors, can be disposable or can be reusable flow sensors. You can choose what you are really adapt with in your hospital. So the flow sensor can be hot wire anemometer, so the dead space is very less, so can be clean and just send it to the CSD to be auto clivable 134 degree. Then you can reuse it again, or you can use the disposable flow sensors. So this one is all kind of our flow sensor can be used. It's really a very important message for all the end users or the doctors or the nurse that you are using the flow sensors should be really careful with the endotracheal and the circuit tube with the flow sensor. Should be careful with the baby positions, the head positions should be in the right or in the left and elevate it a little bit, because the water from the circuit not return back to the flow sensor, then you will have not accurate measurement from the flow sensor. So you have to really elevate it a little bit to not retain the water to the flow sensors. This is really important message for the neonatal or the NICU doctors, RT, and the nurse. So here, what is really a unique in our ventilators in the Leoni Plus, the high frequency principles. As you know, all ventilators, there is a different high frequency principles. In our ventilator, we have oscillator principles. So it's the double membrane oscillator principle, similar to the sensor medics, the old high frequency principle. It's that we believe in our machine that is the most powerful high frequency in the market right now is the Leoni Plus. Why? Because the double membrane plus the oscillator principles making the performance of the high frequency amplitude, it's really accurate and powerful. So this one, the internal pictures for our high frequency, the principles for our frequency, and the regulator to the patient. As you see here is the front screens, is the main screen. Here you can see we have all kind of mode. For the ventilator mode, we have all kind of mode. So as you see, we have the CPAP, we have the invasive IBBV mode is the AC mode in the different terminology, or the IMV mode. We have a synchronized IBBV mode. We have the SIMV mode. We have a pressure support mode. We have all conventional mode plus high frequency mode. You can add with all this kind of ventilator, you can add the volume guarantee, volume limit, and you can shift to the non-invasive without passing to the standby options. Immediately you can shift from the invasive to the non-invasive. As you see in the main screen here, we have all kind of mode. We have the settings here, and in the right side we have the measurement. You have 2 pages. You can select what you like from the measurement, and you have the waveform, the 3 waveform. You can select the types of the waveform, that flow, pressures, or any kind. So here, what is the unique in our ventilators? Our ventilator is overall, including the non-invasive mode, we have overall 38 different modes, along with or combined with the VG or tidal volume or VT limit or pressure support. You have a total of 38 different ventilations mode. So it's really a wide range of ventilators mode can be used for the neonatal populations, and with the accuracy and with a great outcome. As you see here, ventilation mode and additional features, volume guarantee, volume limit, recruitment can be enabled or disabled in user interface. So what is this message? That means if you use the closed system, you will have a limit mode. If you use for a different interface, maybe it will open for you some mode. So not all of this mode can be open for you in one interface. So this also NIV, you can see in the below, we have all kind of mode. High frequency, we are the first ventilators can deliver high frequency non-invasive ventilations for the neonatal populations. Later, I will explain it how we can work with that. So here, as you see, we have a barometer settings. You can set it up. As you see, as you know, in neonatal populations, we have issue with the flow. You can select the auto flow. That means one flow for the both cycle time, inhalation and exhalations. Or to be more accurate, we can also add for you another options. That means you can, as you see in the first graph, the flow for the inhalation and the flow for exhalation in the separate manner. So you can adjust the two flow for one cycle of breath to be more accurate and to save more gas for your patient. How we can do it? As you see, flow consumptions for the two flow, it's more safer to the auto flow. So this one is really great options. If you have a limited gas options, you can use the equal flow options, or you can use as what we are using usually, auto flow, one flow for all respiratory or inhalation cycle. So as you see here, for the start screen, what is the really a new things in our ventilator? I am a RT and I know what is really difficulty in our ventilator, that doing the calibration of the flow sensors while the patient is already connected. The flow sensor is already connected, but they are asking to do the calibration because some issue in the measurements happen. So here in our ventilator can be done the calibration while the patient is already connected. It's the operation of the flow sensor is already running. You can still calibrating the flow sensor. So there is no require from the RT, from the nurse, from the doctor to remove the flow sensor, plug by your hand, then do the calibration. There is no require from you. Just make it on, do the calibration, then they will have the message that the calibration is already done. As you see here in the right side, flow sensors calibration, in the right side there is done. That means it's already done the calibrations. Just select it and make it on. So here, as you see, how you can do the flow sensors calibrations while the patient is already connected and running the ventilations. From here, from this panel, you can see it's look like the hammer. Just click on it. Then you will have here options is the flow calibrations. Click on that, then do the calibration. Then they will calibrate it immediately while the operation of the ventilation is already on. You can collect it and do the calibrations. Also, we have a different message or different panel. Auto oxygen calibration can be done. Auto flush can be done here from this panel. Configuration selecting can be done from this message. So before we start to connect the patient on in the ventilator, we have to done the system test. The system test is the pre-check use for the ventilator. What is the system test including? First of all, they are requiring less than 2 minutes to complete your system test. What is the system test include? The gas supply, air, oxygen, including. If you see the message red, that means the system test is not pass. If you see the message is the orange color, so this one, it's the need from you to be cautious. You need to be carefully monitoring your patients. If you see the message or the color is the green, that means it's already passed the system test. So we are recommending, if you check the system test and all color turns to the green color, so your machine is ready to connect to the patient. Here, as you see, you are checking the power supply, main supply, battery should be more than 60%. Auto sensors, flow sensor should be also calibrated and fit to, and also we have on the right side the functioning test, expiratory valve membrane leak. All this one you have to test it. They are requiring 2 minutes to finish your test after you have all this one green. So that means the machine is already ready to be used in your ventilators or into your patients. So after we finish the system test, we will move to the standby screen. Then after you finish the system test, they will move you immediately to the standby screen. So they have a selections environment sound level. As you know, for if you're selecting the high frequency, should be increased the sound level to the maximum because your patient is very sick and they need to responding to the every alarm message. So we are recommending to keep it in high level. After you finish, then you will move to the start options, you can select the device which respiratory support you are giving to your patient. IV means invasive ventilations, non-invasive. So we have a different two colors, is the yellow for the invasive and the green for the non-invasive. After you selecting the invasive, you will have all these types of mode. You can select, for example, IMV or IBV mode is the AC mode, or you can select the synchronized IBV mode or SIMB, CPAP, high frequency. So what is the respiratory or the patient need, you can select and put your settings. Then you can start with the option of start. Then your respiratory support is already started to the patient. Here we have explanations more in details what you will find in the main screens. For the Leoni Plus, as you see, we have alarm message. Here in the, you will find any kind of alarm message, you will have it in the upper left side. So the alarm in limit indicator, as you see here, this one is for the alarm indicate. You can select it from the alarm set. Here in the green or the long view, we have the trigger samples. So this one, if it's turned to the green, that means patient is already triggering. The curve, you have all kind of curve. You can select what is the type of curve you found it for. If a patient is a flow brushers, so this one can be connected and use it. Also, we have a reading. So as you see, we have a reading from the patient in the right side. We have a reading. As you see, we have all kind of reading. You can select what is the reading really you need to see it. We have a 2 pages, 1 page and 2 pages. You can select it touch screen by your finger, so you can read all the measurement that is come from the patient. So we have the trigger signal here. You can see it in the below. We have the mood also, the mood, all kind of mood. You can select the mood that you are looking for. And in the below or in the last one, you can see the settings. You can just select the or select the number of the settings, and in the right side you have to confirm your set. This one is the main screen for the Leoni Plus. So in details, we have the curves. We have all kind of curves. We have 3 types of curve. We have the flow in the white one. We have the pressures. We have the flow. So as you see, we have in the screen, we have something number of the chart. There is number of 3. You can select, you can make it 1 of the flow chart, or 1 or 2 or 3, as what you are really looking for to read. So we have all kind of a flow chart, flow, pressures, and the volume. Plus, we have number 4 is the clock graphic options. I will explain it later. What is the clock? We have also the plus pulse oximetry options, reading for the heart rate, also for the signal of the pulse oximetry. Can you see it and read it here in the main screen? Also, we have number 6, abdominal sensor trigger, can be read and see it also in the main screen. So you have all reading measurements, graph, flow, pressures, volume curve, all kind of monitoring. You have it in the Leoni Plus. So here, to continue with the main screen, we have loops. As you see, you can select from the loops panels. If you just click on the flow panels, so you will have the pressures volume loops, or flow pressure loops, or flow volume loops, to indicate if the patient have a restrictive, obstructive, or a combined disease. So it's really a good tools or a good indicator of the patient having issue with the lung. So this all loops, you can up to 2 loops at that same time, you can select it and read it in the left side. So this one is really a good tools to continue measuring and monitoring your neonatal populations. So as you see here, we have in the retrieving data or in the log flow, we have a reference. You can refreezing the functions of the reference loops. You can refreeze it. So after freezing, you can measure it and analyze it. So this one a good tools to really assess your patients and check what is a good therapy for the patients. Continue with the alarm set. It's really a vital things that we need to measuring the alarm limit. So in this panel, and you can see in this alarm options, if you click in this in the left side, you can see they will open for you two options for the alarm. You have in the right side, you have the auto set alarm. Auto set alarm, that mean the machine, they can by default setting the alarm based on the last measurement from the patient. By default, they will set the alarm. For example, the minute ventilation, last measurement for the patient is 5 millimeter. So they will give you 7 upper and 3 lower, plus 2 and 3 upper and lower. It's the auto set. Or if you don't like the auto set from the machine, you can still manually set the alarm. This is really a good tools and to set accurate alarm for the patient. Just click here, manual in setting, auto set, and logbook functioning. As you see, we logbook here for retrieving the data. You have open for you a logbook retrieving all the alarm happened to the patient. How can retrieve it? You can retrieve up to 4,500 event alarm happen back. You can go back. That means up to 7 days, you can back to the alarm set and check what is the alarm happen to the patients. So this one for the log. So we have here the change mode. The change mode from you, if you want to change from mode to mode, you need to select, then they will turn the color to the yellow, then you need to confirm it by start. If you confirm by start, they will shift from the mode to the other mode that you are selected and putting the another mode. So here pre-selection mode with adjustable barometer, yellow color code. So after the pre-selection is started by confirmation, the yellow start button. After you set, then you will have the confirmations for the patient. Then you can shifting to the other mode. Also, you can shift from the invasive to the non-invasive, the same procedure, the same setup steps. You can just select to the non-invasive, select the start, then they will shift to the other mode for the no need to pass by to the standby options. So here we have a trending. As you see in the back, in the front main screen, we have a trending curve. So the trending curve, it's up to 72 hours can save all the trending curve for your patient. So if you are looking for assessing the incidents happen to the patients or research, doing some research or any kind of incidents happen, you can retrieving the data, trending the curve, and check what is the settings during the patient during the night or what is also the trending the table up to 72 hours. You can select the interval time for the trending up to 5 minutes or the less. Also count the real time. You can check it for the real time. Up to 4,500 event in the memory can be saved. You can also integrate it. All this ventilator can be integrated, able to integrate it to your system. What you are using in your hospital can be integrate the Leoni Plus to your hospital. Or also you can retrieve the data from the USB, download all the informations, can be easily download the information, use it, utilize it for studying some cases for some patients or research. So trending is really a good tools to check the patients. Here we'll move to the applications. So I will give for a 15-minute break. Then we'll continue our second lectures about the Leoni Plus. So if you have any questions, any kind of concerns or clarification, please write it up in the chat. So I will try to answer it, or we'll give the chance in the end of the course for 10 minutes to answer by opening the speakers. So now we have 15 minutes for a break, then we'll move to continue our applications, mood, and the high frequency principles. Thank you so much. Yes, guys, please, if you have any questions, as what Ibrahim did, please write up your questions. I will, inshallah, able after we finish, I will try to move to the all these questions and answer it. So after Ibrahim, I will answer it, inshallah. As inshallah, with the next slide, you will find the answers. So please write it up all your answers. Thank you so much. طيب. welcome back. Thank you. Today, I will just, before we start or continuing our presentations, I will try to answer the questions from the chat from Ibrahim. Ibrahim, they are asking what is the benefit of the abdominal sensors. So the benefit for the abdominal sensors is the only, just we need to remember that the abdominal sensors is the non-invasive procedures, only sensors touching to the abdominal of the baby. So to make better synchronization of the breathing. Okay, it's only available or active only in non-invasive mode. For the invasive, cannot be used the abdominal sensors. So this one, abdominal sensors, is only for better synchronization of the breathing with the baby, to make the synchronization better and improve the work for breathing of the baby. So it's only active and used for the non-invasive mode. And the specific non-invasive mode is the synchronization IBBV. So not all the mode, not in the invasive, could be used because we have triggers, pressure and the flow triggers. So for the invasive, for the abdominal sensors, is only making the synchronization better and improving the work for breathing or the for the patient. So Abdullah, they are asking also, is the abdominal sensor act like the NAVA mode? No. NAVA mode is totally different than the abdominal sensors. The NAVA mode, it's a real mode used by the NGT sensors. So they can insert the NGT with specific NGT, there is a specific sensors behind the heart, close to the diaphragm, to just measuring or sensing the diaphragm contractions, to be better spontaneously breathing. So for the abdominal sensor is the not invasive, is not, they are not requiring the abdominal sensor, not requiring the NGT. It's only a sample or abdominal sensors touching in the abdomen of the baby. So this one is abdominal sensor is the non-invasive. For NAVA mode is the invasive, inserted by the NGT, and it's really real mode. This one is only abdominal sensor, only better abdominal trigger or synchronization. So the questions also for Bashir, what is the difference between transportation ventilator red and ICU ventilator? There is only the difference that the red one is approved from the FDA for the transportations, for the flight mode, for using through the within hospital transportation or outside hospital transportations. For the non-red one or the ICU ventilator, it's only approved for the ICU, inside the ICU ventilator. So the mode, the options, everything is the same. Only the difference for that is this one is approved for the flight mode and for transportation. Does the transportation ventilator support the mini gas? Yes. Mini gas? Yes. Cylinder? Yes. Can be support and can be save the gas cylinders, and you can transport your patient through the oxygens. Is the built in the turbine air? Yes. It's built already turbine technology, so only requiring from you to connect the air supply, but you have to make sure the oxygen air supply consumptions is very high, so you have to make sure the oxygen consumptions for the high frequency. For example, if you turn it to the oxygen, you need to have a more oxygen supplies, because as you know, the oxygen, the high frequency, they are consuming more oxygen during this mode. We said that the weight range is 350 gram up to yes. We again مشعل العتيبي, yes, for the high for the Leoni Plus, starting from 350 gram up to 30 kilo. So it's covering neonatal and the pediatric populations. So this one for answering the questions. Now I will continue our presentations. So for the applications, as you know, we have all kind of mode, as I remember or I mentioned before. So we have the ventilator mode. CPAP, as you know, CPAP can be used for the patient while of invasive or non-invasive or any kind of that. So this the concept of the CPAP, continuously positive airway pressures, for the patient is breathing spontaneously in the upper pressures. So this one can be also selecting the backup. As you know, CPAP, they have to select the backup breathing and the apnea time to measure the patient. For the IBBV, it's the like IAC mode. So the IBB mode is the ventilation mode. You will be either by IBBV mode or IMV mode, intermittent mandatory ventilation mode, depending on your setting. You have to differentiate when the mode will be IBBV mode, that mean pure uh, AC mode, or when you will be IMV mode. So depend in the expiration time. If the more than 1.5 second will be IMV mode. So as you know, the IMV mode or the IBBV mode is the intermittent positive pressure ventilation. Ventilation follow a pattern set in the device without reference to the any spontaneous mode. That means it's the pure mandatory breathing. But for the IBBV mode, or for the IMV mode, if you increase the expiration time to 1.5 seconds, that means you give the chance or you open the window for the patient to take the spontaneous or additional breath. This is the difference between the IBBV mode or the IMV mode. So it's depend in the expiration time. So here is really a clear explanation about this mode. So here the IMV mode, as you know, it's mandatory breath. In between there is a patient can trigger more, and again they can have also mandatory breath. This one, if you set the expiration time more than 1.5 seconds, that means it's IMV mode. The IMV is the intermittent mandatory ventilation. The patient is allowed the options of the spontaneous breathing between the ventilations stroke. So this is the difference between the IMV and IBBV mode. So here we have also the other mode is the synchronizations of intermittent positive pressure ventilations. So this one is additional pressures or additional mode. They can every spontaneous breath of the patient activate as a mechanical breath stroke by the ventilator. So that means in this mode, patient can be trigger each breath. Then the machine, they will continue complete the inhalation and the exhalations. This one is close to the SIMV, only the difference that there is no pressure support. So here in SIMV, as you see, you can set it up all the SIMV. The good things here, you can in or off the pressure support. For this SIMV, you can add SIMV plus pressure support, or you can make it pure SIMV. So the SIMV is the patient can breathe spontaneously between the mandatory support ventilation. So here, as you see in the graph, or the waveform, the patient breathing mandatory, then the breathe spontaneous, then the breathe mandatory. That means you give the chance to the patient to what? To breathe breathe spontaneously. So here, as you see, we have options for the pressure support off and pressure support on. What is the difference? If you make it off, that means the breathing of the spontaneous breathing, they will start baseline from the beep side baseline. But if you make the pressure support on and you set the pressure support of 8, that means the pressure support or the breathing spontaneously they will take from the 8 pressure support. So you can make it pressure support off or on based on that the patient they can breathe spontaneously based on the beep level or pressure support level. This is the SIMV. Also, we have the combined mode. So you can have the pressure support plus SIMV synchronizations. So this one can be really helpful for the weaning phase. As you see, the pressure support SIMPVV, pressure support ventilation plus synchronized intermittent positive pressure ventilation. So this one is inspiration and expiration is triggered by the spontaneous breathing. So the breathing frequency and the inspiration and the expiration time are set by the patient. So who's decide to have how much the breathing? The patient. How much the breathing can be decide the patient. But you can see in the red signs, we have still you can set it up the backup rate and the backup time. So as any, if the patient have apnea or anything, so they can back to the rate. So all breathe are machine support in combination with the pressure support. It's really a great mood to weaning the patient and start to have the weaning if the patient start to breathe spontaneously completely. So this one also we have a combined mode for pressure support SIMV. As we mentioned, you can have a pressure support plus SIMV if the patient breathing spontaneously can breathe the pressure support or the spontaneously based on the pressure support level. This one for the ventilation mode. Here you can see the pressure support SIMVV mode and the pressure supports SIMV mode. What is the main setting here? We have a pressure support inspiratory set, beep, flow. You can set it flow inspiratory and expiratory, or you can make it one flow. So you can make it auto flow. That means you will have one flow for the both inhalation and exhalation. And we have inspiratory time max. We have a trigger. You can make it triggers flow, pressure, volume as you like. Then you have here a backup for the frequency backup and inspiratory backup. Here we have VG and volume limit. Make it off. That means there is no options to add in this mode VG or volume limit. You can make it off, or you can make it on. Then you can select how many ml per kg you need to ventilate the patient by VG. So this one is the for the set. And here in the SIMV, you can check here. We have a pressure support, pressure inspiratory, and we have beep, flow, inspiratory time, triggers. We have the VG limit, the same set. Only the difference that the patient they can add the pressure support or without a pressure support, or the different mode SIMV or SIMV pressure support or SIBBV pressure support. So here, as you see, we have the ventilation mode combination with the pressure support. You can make it on the pressure support. So after you make it on the process support, you have to select how much the process support, 16, 12, up to what you like. So you need to select the process support. So the adjustment of the process support and the process inspiratory and the process support, they will have the total pressure including the beep. So this one, it's really important for you to check the BIB for the patient. So the pressure support or the inspiratory pressures, including the beep, they will have the total pressures. So here we have our high frequency options. As you know, what is we mentioned before, there is a really a unique features for our high frequency, that the frequency for high ventilation frequency is the breathing is air is made to produce high frequency oscillations, which make it easier to eliminate the CO2. If the patient breathes spontaneously, the ventilation device does not support or assist the breathing, because you will need to have a pure amplitude. So the only positive pressure similar to the beep can be generated for the inhalation and the exhalation, which is significantly reduce the effort to the breath requiring by the patient, as you see in this figure. So the spontaneous breathing for the patient, you will be in the what? In the beep level or the main airway level. For if the patient is triggering, the machine, they will not support the patient to have the amplitude. This is a really a good and important information for this. The high frequency ventilation mode is also possible when the flow sensor is the switch off. This is really a message for all RT nurse and the doctors in the NICU. You can ventilate in our Leoni Plus ventilator. You can ventilate the patient, having the measurement, some measurement, the major measurement, not all the measurement, if the flow sensor is the switch off. We recommend to make the switch off the flow sensors during the high frequency mode. But in the other conventional mode, no, you have to connect the flow sensors. This is really important message. You have to read it. And for the leakage deductions, maybe we will have questions about the leakage deductions, how they can compensate. Make sure that the pressures, main airway pressure alarm is correctly set. If you correctly set, sure that the machine, they will compensate and deducting if there is any leak. So this one for the high frequency ventilations. So moving to the non-invasive mode, if you see in the main screen, we have a small n, then we have a CPAP. That means a non-invasive CPAP. You are on non-invasive CPAP mode. So non-invasive CPAP mode is a common mode used for the baby as maybe high flow CPAP as a first stage to respiratory support the baby. It's also recommend to use it if the patient is stable, premature, it's not premature, or still having develop all the main organs. So we recommend to start with the least support like high flow CPAP. If patient still requiring more, then after that you have to escalate the ventilation. So the CPAP mode is the patient breathes spontaneously, a positive pressure similar to the beep is generating both inhalation and expiration. So it's really significantly reduce the effort to breathe by the patient, also improving the oxygenation for the baby by increasing the functions residual capacity in the lung. So it's really important. So what is the flow? We have here the two types of the flow. We have automatic flow off or you can make the flow main or flow CPAP. You can adjust the flow CPAP based on how the demand the baby need. You can set it manually. So every mode, if you click on this mode, you will have a CPAP. If I2, then you will have a flow. You have to set it man or the flow CPAP manually. You can set it up. We recommend to start with 5 to 7 liter. After that, you can go down or up based on your patient situations. So here, as you see, okay, here we have a different mood. As we remember, we have a S is mean synchronizations, and non-invasive, that mean we have synchronization nasal continuously positive airway pressures for the what, for the non-invasive ventilations. So this mode is the patient breathe spontaneously, a positive pressure similar to the beep is generating on the both inhalation and exhalation, which is significantly reducing the effort of the breath. If the patient stop breathing spontaneously, the ventilator activate the backup respiration to stimulate the patient spontaneous breathing with the specific ventilation barometer. You can select it and adjust it. So if the patient have apnea, as you see here in the interval number 2, we have apnea. That means we have to initiate the mandatory breath or the backup breath for the baby to support him. So this one is really a great mode to support the baby with a backup breathing. So here also, there is no need for the synchronization mode. The flow sensor should be automatically switched off. So this one not requiring from the end user to connect the flow sensor for the non-invasive options. So you can use this one. So this one for this mode. Also, we have a non-invasive nasal intermittent positive pressure ventilations as a non-invasive mode. This one is the like bi-level pressure or BiPAP pressures. So this one is like also cycling CPAP. So this one also, if the patient cannot tolerate the CPAP or they need more respiratory support, so you can escalate him to be more by level 2 level of pressures. So the nasal intermittent positive pressure ventilation is performed when the pattern set and specified by the device without taking account of the possible spontaneous breathing by the patient. So you have to set the rate, you have to set the pressure max, the inspiratory pressures and the beep pressures. So patient, they will have 2 level of pressures with the specific time of the breathing. So if the patient is possible to generate a specific pressure automatically by the automatic flow on, or you can use this set the flow by manually. So this one is the a good mode for if the patient still need more respiratory support to avoid the intubations for the baby, or the patient is on higher setting in CPAP and you are really planning to shift him to the more support. So this mode is really a great mode to set it up and make sure having a good and proper settings for the inhalation and beep level and backup rate. So also we have a synchronization nasal intermittent positive pressure is the same mode, plus only they allow the patient to trigger each breath. Before this mode is all the breath from the ventilator, but for this one, if you have or read any synchronizations, means each breath should be triggered by the patient. So this one also having more support, but still you give the patient a chance to having spontaneously breathe by patient activate and mechanical breathing. So also we need to move to the unique options. The first ventilator that they have this options in all market, all ventilator, it's the our ventilator Leoni Plus, is the new mode nasal or non-invasive high frequency ventilation. Is the first ventilator in the market that they providing the nasal high frequency oscillations. So this is different than high flow. This is high frequency oscillator ventilations, showing a promising evidence from a worldwide. There is some study showing that if there is FI2 or the baby is requiring more than FI2 60 per minute or 60 FI2 percentage, they are all immediately shifting to the nasal high frequency ventilation. So it's showing really a great outcome by reducing the re-intubation rate, decreasing the length of stay in ICU, improving the work for breathing for the neonatal. Here the explanation how the nasal high frequency oscillation concept. So the breath air is made to produce the high frequency oscillation, which is make it easier to eliminate the CO2. If the patient breathes spontaneously, the ventilation device does not assist the breathing. That means they will have a clear main airway pressure with high frequency ventilations and have a large main airway pressure. So helping with oxygenation with the large main airway pressures and eliminate the CO2 by high frequency. So can be generated by for inspiration and expiration, which is really significantly reduce the effort of the breath. The ventilation pressure may be negative during the exhalation phase. For the leakage detection, make sure to select the main airway pressure alarm is the selected correctly set. What is the good things in the nasal high frequency? When the operator switch to the nasal mode, high frequency, the flow sensor is automatically switch off. So if you switch it off, what will happen? The flow sensor is automatically switched off because the expected high leakage rate. So what is the ventilator they will do? The volume control would you produce incorrect information. So the flow does not change in response to the leak. However, the device is able to maintain the pressure even with the high leakage rate by controlling what? The expiratory valve. So the ventilator, even if there is a huge leak, still they are able to maintain the pressures with the high leakage rate by what? Controlling the expiratory valve. That means they will they can able to compensate the leakage when you're controlling the expiration valve. This one is really helpful, can be utilized as an additional interface for the neonatal if the patient on CPAP, then moving to the BiPAP or cycling CPAP. If failing, you can add additional interface is the nasal high frequency. So you can try it before you got intubate the patient, showing a promising evidence for this. How you can collect it or what is the interface? we can apply the nasal high frequency with any interface. Any interface, nasal interface, for example, the new jet interface or the facial umbilical interface, you can put it in the nasal and you will still, you have delivered the high frequency ventilation. Here we have the high flow oxygen options. As you know, we explain how you can connect the high flow setup. So still you can provide the high flow for the neonatal population by any kind of interface. You can generate the high flow up to 20 liter per minute. So you can select how much the flow you need to deliver to the baby and the FI2. So this one, it's really, we recommend to be the first stage respiratory support for the neonatal as a non-invasive therapy. If not, you can then escalate it to the other respiratory support. So the high flow, as you know, still we have it with our neonatal. So here in this slide, we have configurations. The configuration is the, as you know, before we start, you have to configure all your set. Just move to the service, then configure all the set that you are requesting to be showing in the main screen. So if you want to see the IBV mode, SIMV mode in the main screen, just you need to select yes, VG yes, everything. Then after you save it, then when you open to the main screen, you will have it in the main screen. So this one should be adjusted initially and fix it initially by the biomed or by the supervisor of the RT or the doctors initially when you start or you have the ventilator. So just service configurations, then select all the mode. You can select all the mode or a specific mode that you are looking for it. So here we have the VG. As you know, we have the options of the VG. Volume guarantee is very vital, very important for the neonatal population. We have it. You can only add the VG by on or off as you like. So the VG is the specific minimum volume that must be reached with the ventilation. It's the definition of the volume guarantee. The device is automatically generating the necessary pressures so to achieve the volume. The ventilation pressure cannot exceed the pressure max. So if you put the pressure max as a safety, so they cannot exceed it because the safety for the neonatal and avoid the pressure trauma or the volume trauma. The volume generate control does not apply the pressure support breathing. So every mechanical breath, so the patient, they will have the VG. If the spontaneously, no, they will have his own effort. So when the volume generate is deactivate, what will happen? The current measure value is applied. What is the set in the pressure measured? So they will targeting by the machines. If you make it off, the pressure or the delivering volume, they will depend on the set of the pressure that you are using. So here the message, Pmax is the specific ventilation pressure that may reach in the volume guarantee ventilation. You can find the Pmax on all this mode. You have to set it up. If you found it in synchronization IBVV, SIMV, you can make it off or on as you like, as you see here in this graph. So here we have functions of the VG. As you know, for the high frequency, you can add the VG. For the high frequency, that means you have high frequency plus VG, or you can have high frequency pure without the VG. It's depend on the patient situations or conditions. Just message for all the end user: if you make the VG on, you have to check that the amplitude, it's open window, it's change the name of the amplitude to the amplitude max. That means the open window to adjust the amplitude to achieve what? To achieve the volume guarantee that you are set. For example, you set the volume guarantee 4 mils per kg. So the amplitude they will be adjust up and down until to reach the volume guarantee that you are set it up. If you make the the volume guarantee off, then the amplitude max, they will remove the max, they will make it a clear and pure amplitude. This one, it's really important message for end users, also RT nurse doctors. So here, as you know, a volume guarantee, you can adjust it or you can configure it from the configurations. So you can just go configuration, volume guarantee, make it on or off. So you can also in the, if you check the volume guarantee both, so we have also features, functioning features. You can pause the volume guarantee. For example, if the patient is suctioning, during the suctioning, closed system suctioning, you need to pause the volume guarantee. You can pause the volume guarantee for 180 seconds or 90 seconds. Then after that, they will back again the volume guarantee. This is the really great options for neonatal populations. You can make it on, pause, off as you like. So the high frequency principles, it's really unique and important for us. The high frequency with the double membrane, controlling the amplitude with the setting in centimeter of water. You will have a variable IA ratio, recruitment frequency, volume guarantee. All this one can be have it in the ventilator. We have the new features, nasal high frequency, non-invasive, also with adaptive barometers. So for the high frequency can be internally connected to the inspiration board. Also, you have amplitude more powerful, reaching to the 100 amplitude. If there is no leak or the connections is really proper connections. Also, it's open system, can be used the high frequency circuit, any kind of circuit. So this one, it's really cost effective for the operations, less cost for the end user. You can use any kind of circuit for the conventional or the high frequency. As you know, here in this slide, we have a clear explanation. Here, what is the concepts or the basic informations about the high frequency? High frequency, delivering a very small volume, even smaller than the dead space, 2 ml per kg, are extremely with age with the high frequency, reaching from 5 to 20 hertz per minute. So the high frequency ventilations is the unique, and the exhalation is generating actively, whereas the form of the high frequency exhalation is the passive. But what is the unique in our Leoni Plus? The Leoni Plus is realized by applying a continuously pressure, main airway pressure, for the whole respiratory cycle. That means the oscillation of the gas column contained in the airway is achieved by what? By the active double membrane. So the two opposing membrane oscillator in the two phases. So this translates into respiratory cycle in both phases. So in both phases, inhalation and exhalation are active. It's not only inhalation and exhalation passive. No, inhalation and exhalation are active. It's similar to the sensor medics principles. So the Leoni Plus is perhaps one of the most powerful combination ventilator or high frequency in the market right now. So what is the difference in other market? For the high frequency flow interruptions, the other market, in, for example, Draeger, Steven, McKay, it's all is the flow interruptions. But in our ventilator, it's the principles is the oscillator principles. So here we have the explanations how the inhalation and the exhalation and the main airway pressures. So the frequency is depend on the stroke of the how many strokes that they are reached. And here we have in the table, you can see the main airway pressure can be reached from 0 to 40, the maximum. The high frequency can be from 5 to 20, not the 15. The amplitude reaching from 5 to the 100 centimeter of water. The frequency oscillator from 1 to 60 per minute. The I ratio is not fixed. You can make it from 25 to 75, 1 to 1, 1 to 3, 1 to 4. You can adjust it based on your patient condition. So it's not fixed as 33%. You can make it 1 to 1 or 1 to 2 or any I ratio that you are looking for the patient or fit for the patient. Here inside, what is the principal positive amplitude? As you see here, the double membrane, this the white one is the double membrane, and the gas is coming from and toward, then the oscillator on and off, forward and backward. So this one is the positive amplitude. The negative amplitude when the air comes out. So making the very powerful performance of the frequency. Here we have the setting of the high frequency in the main screen. As you see, we have the main airway pressures. As I said, we have high frequency you can set. We have amplitude. We have I ratio. We have here frequency recruitment, time recruitment, pressure recruitment. This settings is only active during the manual breath. During the site breath, if you activate the site, this setting they will be active. If you not activate the site, so this one is useless, is not active. So here the VG, you can add the VG on or off. While as you see here, the VG is on, off, that means the amplitude is pure. If the VG is on in the below, as you see, the amplitude max, that means it's open window for adjusting the VG to reach the proper tidal volume for the bass. Just make sure that the recruitment or the frequency REC is the means recruitment. So this one is only active. The three settings is only active if the manual breath active or the site is like is maneuver. It's like the maneuver. So here a great options for the neonatal population. It's only found in our ventilator. It's not, you can find it in any ventilator. It's named CLAC system. CLAC system is the closed loop automatic oxygen control. What is the CLAC system? CLAC system, it is a module from the ventilator, as you see in the figure or the pictures. Baby is connected with the pulse oximetry. It's the Massimo pulse oximetry connected from the back of the ventilators. So after you connect the pulse oximetry to the baby, then what we'll have here we'll see in the next slide. After you connect this, the pulse oximetry, as you see here, the pulse Massimo set oximetry cable and SpO2 sensors cable. It's reusable, can be used, clean it and reuse it again with the different patient. So what we'll have in here in the module, we'll have the perfusion index PI to check the indicator arterial plus single strength. Also, we have a signal IQ for measuring the quality of the pulse oximetry or the Massimo pulse oximetry waveform. After you finish this one, connect it and you make sure that the SpO2 and the sensor is connected properly to the patient. So what we'll have here, we have the main screen. They will open window for you. Name this window is the closed loop automatic oxygen control. They will open window for you to target the SpO2 target. As you see in the color, we have a red, yellow color, and a green color. And for example, you make the saturation, acceptable saturation for the baby 90 to 94. So 90 to 94 is the green zone. If less than 90, you will be yellow. If it's really less than 88, so you will change to the red. Also, if the patient receiving too much oxygen. What is the great and the unique options here with the pulse oximetry and the closed loop automatic oxygen control? If the saturation goes below the 90, the ventilator, they will adjust the FiO2. They will auto adjust the FiO2. There is no need from the RT, doctors, and the nurse to adjust the FiO2 every time. So just set it up. Then they will increase the FiO2 and decrease the FiO2 based in the acceptable saturation that you are set it up. Maybe I will receive questions. Maybe we don't want to receive the baby too much oxygen. Yes, you can adjust the adjustment or the increment of the FiO2 by 1, by 2, by 3, depend on the that you are set it. So as you see here in the green or the color, that the FiO2 can be changed, adjust the FiO2 by this machine. This is the really a unique features, only found it in the Leoni Plus. Helpful, it's really helpful for the reducing the manpower for the RT, for the nurse, adjusting the FiO2 by the machines. So as you see here, we have the closed loop automatic oxygen control. So this one is the only scenarios. If the patient having suddenly really desatting down immediately to the 70. So we have a scenario here. The FiO2, they can shorter the time of the analyzing the SpO2, then increasing the FiO2 by 10, by 20, until the back again to the green zone. Here also the another scenarios. This one you can configure it and set it up in your ventilator. Here, as you see in our ventilator in the main screen, closed loop automatic. After you connect it and turn it on, they will have here these pictures, 90 to 95. If is within the green zone, that means patient is well oxygenation. If it goes below, that means the FiO2 they will increase by himself. All scenarios here. Also continue with the scenarios, with the emergency scenarios. So clock system is really a great options. Can be read more about it. we can send more about it and how to connect it. If anyone interested to see it, just send us the interest, then we can show him how to do it. So here we have the closed loop oxygen automatic control. As you see here in the main screen, we have the pulse oximetry, the saturation of the baby, and we have the FiO2 set. So there is interval time, for example, 180 seconds. If the interval time go below the set time, so the FiO2 will increase and decrease based on the white signs is the what is the saturation of the baby. This one mean a closed loop clock system. What is the good things in the closed loop oxygen? So after you connect it and make sure that it's already adaptive, you will have the saturation upper and lower alarm set. You can set it as alarm. Also, you will have additional heart rate as a upper and alarm as a small monitor. So this one is really a clear and a great options for the neonatal. You can configure it here from the configuration from the service, make it on to start your closed loop automatic oxygen. Clear here, as you see in the left side, you have the FiO2 message, and the white one is the saturations. The NIV, we have the new jet system. So a new JIT system, I think will explain that the new JIT is only interface can be used, or any kind of interface. It means a new JIT can be used for the non-invasive, high flow, any kind of the new JIT. It's really a great or a good interface for the neonatal population. You can use it and utilize it for this, for the neonatal. Reducing the work for breathe, non-aggressive flow applications, increase the FRC and improve the low noisy level for the neonatal, the new jet. As you see here, you can still having the new jet or the the facial umbilical system as the closed system. And okay. So this one for, as you see in non-invasive, you have a 3 interface. You can select high flow interface from the non-invasive, or new jet high flow, or high flow, regular high flow, or closed system. If you want to select high frequency or BiPAP, nasal CPAP, you can select what is the interface. You can select it in non-invasive. So here on the non-invasive, as you see, you can just select a non-invasive high frequency, then select start. They will shift to the non-invasive high frequency. High flow, I mentioned also. The setup for the high flow patient. I go through this and I already explained it in the early slides. Here, the last one is the abdominal pressure. As one he asked me, what's the abdominal pressure? This one is the sample line abdominal, and this one should be stick in the abdominal, close to the diaphragm. Then they will apply, synchronize the nasal intermittent pressure. It should be activate only in the 2 mood. Okay, this one, what is they will do? The diaphragm or the abdominal breathing is very pronounced as our smallest patient. With the respect to that, they could be better than monitoring the children breathing activity by diaphragm and using the signal obtained here, the trigger of the inspiration. So this one, the abdominal trigger, as you see, if you connected the abdominal trigger and you make it on, so the green color in the main screen, you can see it. It's the trigger, abdominal triggers. So this one giving better synchronization for the baby. Okay. This one for the NO connection, it's compatible with any kind of device. for the nitric oxide, you can connect it through the expiratory valve membrane, or you can connect it. So this the last slide, and really I would like to thank you so much for listening, and we'll continue to have, because the time is running, so we'll receive, if we receive any questions about it, I would be appreciate if you ask me any questions about the high frequency. So hello, if any questions or any, I will open the, you can write up any questions that you are like to ask. You can ask me, please. So we have 15 minutes to answer any questions or any kind of clarification. Just ask me. I will open the mics for any questions. So the mics now will be open. So if anyone would like to ask, please. Okay. Meet options. So so any please questions? Still we have time. Any clarifications, please ask. يعني لهالدرجة كل شيء واضح. فبليز يعني ask any questions، يعني أي clarifications regarding اليوني بلس or any any هذا you can just communicate or.
It was a really great presentation, a lot of information. I would like to know, when you're comparing to the Dragger neonatal ventilation baby log VN
Yes.
series, so how your high frequency ventilation is better? Can you explain it a bit more?
Yes. Yeah. So as you know, the most powerful high frequency in the market before is the sensor medics. Why the sensor medics? The old machine, because the principles of the high frequency is oscillator. That means they need the breathing, the oscillator is back and forth for the oscillation principles. But for the new generation of the ventilators is the flow interruptions. That means is depend in the valve, open and close the valve and open. So the powerful of the frequency is not like the piston principles. So when we have a neonatal baby, sick baby, they cannot, and with the severe ARDS or stiff lung, you cannot ventilate the baby because of that. So you need to have a more powerful high frequency can provide the oscillator principle. So only our ventilators and the sensor medics, what I remember that is they have the oscillator principles. The other ventilator, it's only flow interruptions. So this is the questions. So how much the max pressure we set for the adult and the pediatric? So you mean for a high frequency mode or in other mode? If we are talking about pediatric and neonatal population, so high frequency, we have amplitude pressures can be reached up to 100 centimeter of water can be reached in 100, but it's very rare to reach on this because you have to based on your amplitude, based on the wiggling of the breath. If the wiggling is enough, that means there is no need to increase the pressures. Maybe the wiggling is more than enough in 40. So why you need to increase? So this one is a good tool too, but you have the window from 5 to the 100 amplitude of pressures. For the main airway pressures, we have 5 to 40 centimeter of water for the main airway pressures.
Okay, thank you very much. Thank you, Mr. Saad.
Welcome, welcome. Any questions? If the patient, there is one question, if the patient have a nasal, okay, nasal will effective high frequency. If the patient have a nasal probe in adult. So for the high frequency, we are not recommending to connect it in adult. Adult, there is a smart mode, advanced mode like ABRV mode. So it's very rare to using the high frequency for the adult populations, and we are not recommending really to connect the high frequency to the adult. But for neonatal and pediatric, yes, it's really helpful and they showing promising evidence, promising outcome. So if they need a specific circuit for the HIV? No. For our ventilator, there is no need to having a specific circuit. Can be used any kind of circuit. So this one, it's really a great features. Open system can use any kind of circuit for the high frequency or non-high frequency or conventional. You can use one circuit. We have so guys, we have 5 minutes, more than 5. Any questions, any clarifications, please يعني. طيب ما في أي سؤال. طيب, so far I would like really to thank you all for attending our first online course, Azeer, and this one will not be the last course. No, just the beginning. So next time we promise you that we will do the course with really CME hours, and will be really a great with the great speakers and different healthcare workers. So for the certificate will be inshallah sent to your emails. We'll check the attendance. those who attending the online, they will send to them the certificate. So just please don't leave the WhatsApp, because we'll send all the materials, the presentation materials. Then after that, we'll give you some information about the time for receiving the certificate. Questions: how can we give nebulization? Is the normal setup. Just you need to YBs, then connect the nebulizations, so you can connect it. Is there semi? So this one is only certificate. Next course, inshallah, they will have the CME hours with different type of topics, inshallah. So thank you so much. I really appreciate your attendance. So you can leave now. See you. Thank you so much.